Hello everyone. So let us see the maximum power transfer theorem with respect to the electric circuit analysis. So here this maximum power transfer theorem states that whenever the source resistance is equal to the load resistance, the power transferred from the source to the load will be maximum. The meaning here is, it states that if you have a source, let me take a voltage source. If the internal resistance of this source, let me take a say R in, if this is equal to the load resistance RL, that is R in is equal to my RL, at this condition the power transferred from source to load, it will be maximum. This is the maximum power transfer theorem. So let us take a simple problem and we'll try to analyze how this maximum power transfer theorem will be solved for a given circuit. I'll take a simple problem. So, which has a source of 100 volts, which is of AC source, 100 volts at an angle 0. So the direction of the voltage source, or polarity of the voltage source, is given the upward. So with the resistance in series and it parallel with the X, that is J10 ohms, this is 20 ohms, which is once again parallel to the resistance RL. So this is a circuit given, so where I need to find the value of RL. I need to find the value of RL. This is a question given for this problem. Let us see how to solve this. So similarly, like we have been seeing many theorems similar to those theorem. First of all, when you want to find any values across any resistor, we try to open that. The same way here also, I rewrite the circuit by opening the resistance RL, right? Or I can say that if you remember the condition, RL should be equal to R in. The load resistance should be equal to my source resistance. So based on this, I need to find the equivalent resistance of this circuit. So how do I do that? I can find the equivalent resistance of the circuit, or Z equivalent, because I have a J also. Z equivalent can be determined by short circuiting the voltage source, by short circuiting voltage source and opening load resistance. Opening load resistance. I will rewrite the circuit by doing this. I will be shorting my voltage source and it is left out with 20 ohms. It is in series with J10 ohms, and I will open the terminal. Let me take this as a, so I will give the name here also, A and B. Okay, you can give any name just for indication, so where the load was connected over there. So now I can determine the equivalent, that is Z equivalent is equal to, which is 20 ohms is parallel to J10, right? Is parallel to J10. So if I find the equivalent of that, 20 into J10 divided by 20 plus J10, which will give us answer as 8.94. I'm writing in terms of polar form, 8.94 at an angle of 63.44 ohms. So from this I can also get the value for your RL will be equal to, because RL will be equal to Rin, I said that. So if I take a magnitude of this ZTH or Z equivalent, which will give us 8.94. I'm considering only magnitude, that will give my RL value. So next I need to find the voltage. Since I want to find the current R over there, if I know the formula, I is equal to V by R, right? So once I know that, it will be easy to determine the resistance value over there. So first I will determine the open circuit voltage for the same circuit, considering a voltage source that is 100 at an angle 0, which will be of 20 ohms in series, and impedance of J10 ohms at terminal A and B. So I will find the open circuit voltage VTH, which is also equal to, I can write a VAB also, because the terminals are A and B. So VTH will be equal to, V is equal to I into R. So I will be nothing but V by R. I is equal to V by R. So if I take this, so or else I will first find here separately I is equal to V by R. So V is given as 100 at an angle 0 divided by 20 plus J10. If I simplify this, I will get the answer as current as 4.472 at an angle of minus 26.56 amps. So this is the current I will get. I can substitute directly instead of taking here. I will take directly. That is the magnitude I will consider whole, that is 44.7 it is. 4.47 it is. 4.472 at an angle of minus 26.56, and R is, if you look at from this point, R is J10, it is J10. So finally I will get, if I simplify, I will get the answer as 44.72 at an angle of 63.43 volts. So this is the voltage we will be obtaining. So once I know this voltage, and already I have got here Z also, ZTH, I got voltage, so I can rewrite the circuit. So this is my VTH value, which we got 44.72, and I have a ZTH which we got already, that will be connected to my terminal A and B. Within the terminal A and B I have a resistance, that is RL, and the current flowing through this will be, I can take it as a IL. So I need to find the current IL now. IL will be equal to, so VTH divided by sum of the resistance, that is ZTH plus RL. So where VTH 44.72 at an angle 63.43 and ZTH, so it is of 8.94 at an angle 63.44, and RL is 8.94. If I simplify that, you will get as 2.94 at an angle of 31.71 amps. This is the current in the circuit. And also I can determine the power. So maximum power P max is given by IL square into RL. IL square into RL. So IL we can consider only magnitude I written. that is 2.94 whole square into RL, we got already in the above 8.94, so which will give us 77.27 watts. So this is a solution. So actually we are supposed to find the RL value which we got here directly. So once you get RL, I can calculate that by writing the equivalent circuit for a maximum power transfer, and I can determine the maximum power for that RL value. So this is a solution for this. So, thank you.